Hey there, welcome to Book Overflow, the podcast for software engineers by software engineers dedicated to discussing the world's best technical books. I'm Carter Morgan, and I'm joined here by my co-host, Nathan Toups. Nathan, how are you doing today?
Hey, I'm doing great. Happy to be here.
Great. Well, I think we're really excited about our book today. I think we both really enjoyed it. I will give a quick overview of the book for all the listeners joining in, and then we've got a lot of great discussion headed your way. So, the book we read this week was A Philosophy of Software Design. I'll probably butcher this name, but it's written by John Ousterhout. He is the Bosack Lerner Professor of Computer Science at Stanford University, the creator of the TCL scripting language. I've personally never used that, but I trust him. And he teaches CS 190 Software Design Studio at Stanford. I think something Nathan and I both agreed as we read this book was we were very jealous of any students who got to take CS 190 at Stanford. It's a class. We're going to learn more about that as we kind of discuss the book, but it's a class about really the philosophy of designing software. And so this book is, in essence, his high-level philosophy and what he's tried to instill in his students in that class. And he was generous enough to make it available to everyone for $8 on Amazon. So we are really grateful for that. Nathan, what did you think of the book?
Yeah, I was in the same. I was pleasantly surprised when they say, philosophy of software design. It really is deeply philosophical. Thought that was really neat. And yeah, same. I wish I could have taken that class. Actually, it seems like a really unique class anyway. I was watching a Google Talk, and he doesn't even have TAs because of how hands-on he is with the code review process, and he hasn't figured out how to actually delegate that, which is an interesting side conversation.
Yeah, it's I totally agree about the book. Like you hear that it's going to be a philosophy of software design, and at the end of the day, as software engineers, we're builders, and we got to make things that work in the real world. And so I was a little nervous. I'm like, is this going to be a little too like ivory tower? Like in a perfect world, this we would do. But no, I didn't think that at all. I thought it's philosophical in that it's a book about a lot of principles, but those principles are very actionable and applicable.
Yeah, they reminded me a lot of like I've read a lot of Alan Watts on like Zen Buddhism, and it's very similar. It's like these like little truisms, little proverbs that you read this little statement that you're like, this sounds true, and then he defends it. I also love, honestly, he goes into how you could take any idea too far, and I really appreciated that as well. Right, before he gets to the conclusion of any section, he's like, okay, here's what happens if you take it too far, and I appreciate that as well, because you always see the people can become zealots and take an idea to an extreme, and then it's not useful anymore.
Absolutely. And so let's give maybe a high level overview of what the book is about, and even what this class he teaches is about, right? So yeah. I thought the class was really interesting because in our computer science classes, we tend to focus a lot on the fundamentals, on the theoreticals, things like that. But this class is all about how do we design proper software, and how does he kind of define like what's good software? He kind of says that the enemy of all software is complexity, right? And I just want to right off the bat kind of define how he defines complexity. Kind of gives three components of complexity. He says, 1, change amplification. The first symptom of complexity is that a seemingly simple change requires code modifications in many different places. 2, cognitive load. The second symptom of complexity is cognitive load, which refers to how much the developer needs to know in order to complete a task. And then the third is unknown unknowns. He says the third symptom of complexity is that it is not obvious which pieces of code must be modified to complete a task, or what information a developer must have to carry out the task. So this book and this class he teaches is all about how do we reduce those three components of complexity. And like Nathan, I didn't realize, Nathan, what you were saying, that he doesn't even have TAs in this class, because really what this class is just a never-ending series of code reviews. He'll give the students an assignment like, hey, build a text editor. And then they build it one way. And then it's submitted to him. And then he'll, kind of point out and say, you should do this differently, right? And, what I wouldn't give to be doing regular code reviews with someone with as much experience in the industry as John Ousterhout. So very jealous of you students at Stanford. If you're a student at Stanford and you haven't signed up for this class yet, go do it, because we will be mad if you have this opportunity and you don't take advantage of it. Nathan, there's so much great stuff in this book, right? It's kind of divided into, it's like 20 different chapters, and each chapter is roughly a principle. So there's a lot to talk about there. What really jumped out at you, that you would like to talk about first?
Yeah, it really built well on itself. So, he jumps right in talking about complexity. And I think one of the takeaways that I loved was he said software developers should always think about complexity. And I think that's very true. I'm actually working with a team right now where we have a bunch of legacy code. And he warns about the fact that complexity will creep in over time and that it's death by 1,000 cuts. And it's in that when you actually start trying to write the ship, that you realize that no one fix actually turns into some transformative change. That the way that complexity creeps in, you put all this effort to start fixing it, writing the ship, and it takes a tremendous amount of effort to undo all of the unintentional complexity that creeps in. And then, of course, he goes in and talks about all these examples because, again, that's very philosophical and broad. And I really like the framing of this sort of strategic versus tactical. I think we'll probably get into that. And then he kind of outlines a bunch of like general principles where I've just felt myself nodding my head so much during this book and highlighting. I mean, it's a short book. It's like under 200 pages.
Yeah.
And I think I had like 75 areas highlighted in the book, which means that, basically every other
almost every page.
Right?
Yeah.
Yeah.
No, I thought this book was really interesting because in a lot of ways I think he might call out some of these authors by name at one point, but in a lot of ways it's almost an implied rebuttal to some of the books that are really prevalent in our industry. I'm thinking like Uncle Bob's Clean Code. It's kind of a rebuttal to Clean Code. It's I thought it was funny because I just finished Martin Fowler's Refactoring, which I really enjoyed, and I actually think pairs really well with this book. Kind of like you were just talking about, Nathan, about when you're working with legacy code and you need to be making changes to reduce complexity, right? Martin Fowler has so many great pieces of advice about how to do that. But then he also is a little kind of on the maximalist clean code side. Things like functions should only ever be 10 lines or things like that. So I don't think that these books are enemies by any degree. And I think one thing I really like what Nathan said too, that I think in every chapter, John has a taking it too far section to say these are principles, these are guiding forces in how you should be considering your software design, but it's not the be all end all. And so to me, I think this is going to enter kind of that essential coding reading material lexicon as clean code. Because I don't think you can read clean code and then not also read this book, because they're so at odds with each other that I just think there's so much to gain by analyzing the tensions between the two.
Yeah. I thought the same with in reference to clean code. I also loved, I took a note here when we were preparing for this episode. He has a lot of contrarian views without being adversarial. Right.
Yes.
So there's not one of these like, oh, well, this is wrong and you should be ashamed. He mostly makes the argument that, hey, this is a common knowledge, except why is it this common knowledge? And is this actually useful? Here's several examples of where you don't want to break a function up into 10 lines of code. That's an arbitrary abstraction. And I think one good rebuttal to that is that it's your responsibility as the engineer to encapsulate that complexity, and that sometimes making a simple interface means that you have to take the burden of writing 30, 40, 50 lines of code.
Yeah, let's talk about some of the ways he differs from Uncle Bob's Clean Code. I think one of those ways, he talks about the idea that modules should be deep, that maybe it's okay for a function to have lots and lots of complexity hidden within it because that abstracts the complexity away from the developer. He talks about, as an example of a deep module, he talks about the mechanism for file I/O in Unix. And he says, this is what he says, it's a beautiful example of a deep interface. There are only 5 basic system calls for I/O with simple signatures, and he lists them. There's the open command, the read command, the write command, the lseek command, and the close command. And he goes on to say that these 5 commands take the entirety of file I/O in the Unix operating system, which is crazy when you think about it. But one of the things he points out is that these 5 commands work because they are general purpose. There are so many different ways you can use these commands, and between just the 5 of them, they really cover the entirety of what you need to do in file I/O in Unix. And he kind of challenges us to think about with our software, he's anti-methods that do one specific thing for the most part, right? Think about a method that's like look up result in database and verify it is 7 or something like that. I think we've all seen methods like that, right? He says that's a shallow method. It doesn't really abstract anything away from the user in this case being the developer calling the method, right? And that we should be trying to establish more deep methods like the Unix file IO system.
Yeah, it's interesting too, because I come from the Go community, and so there's a lot of very specific ideas that I think overlap in some important ways and are a sort of juxtaposition. He even calls out some of this, right? Like we use really, really short variable names when appropriate. But one of the most beautiful things I think in Go is interface design on things like the IO library, and it has a lot of overlap, right? The IO reader in Go has a single method of read, and that actually becomes incredibly powerful generalization for reader and for writer, because I don't have to make a decision on whether that's writing to disk, writing to memory. An IO reader for my web server, it's a very simple way for me to abstract away these read operations with a very specific function signature. And with this, you get this really powerful way of implementing on top of it. And I think it's that usefulness, this like focus on the design phase and the usefulness, and really trying to think about how somebody's going to use a piece of your system. And is there a way for me to reduce cognitive load? He talks about this a lot in the book, which is that, if I, as the consumer of the interface, have to understand every implementation detail, what am I really doing here, right?
Absolutely.
Yeah.
He has a great comment talking about abstraction in that way, where he basically says, and let me see if I can get the exact quote here. Yes, he says, if users must read the code of a method in order to use it, then there is no abstraction, right? Because we see that philosophy too of like, my code is self-documenting, right? The code itself, and I think there's some truth to that, but that was powerful to me, that like, he talks about that idea of abstraction, and that we should just be able to pick up modules and their methods and run with it, right? If we have to do tons of deep diving into how it actually works, then we've designed complex software that increases the cognitive load, it increases our unknown unknowns. There's change amplification, right? Maybe not that particular instance.
He makes another good example of this where he kind of picks on Java a few times, because I think Java is has been a really popular language that's gone through all of the transformations and how we think about systems design from the 90s and all the way till now. And so he kind of picks on it a bit in saying, I actually have to call 3 objects to read a file.
I've got it right here. He talks about you have to create a file input stream and provide it the file name. Then I need to create a buffered input stream and provide that the file stream. Then I need to create an object input stream and provide that the buffered stream. He says the buffered stream object adds buffering to the file input stream, and the output input stream adds the ability to read and write serialized objects. The first 2 objects in the code above, file stream and buffer stream, are never used once the file has been opened. All future operations use object stream. It is particularly annoying and error-prone that buffering must be requested explicitly by creating a separate buffered input stream object. If the developer forgets to create this object, there will be no buffering and I/O will be slow, right? Comparing that, he contrasts that with the Linux command, read. That's it, right? He talks about pulling complexity downward. And one thing I love throughout this book, he talks a lot about APIs, right? And I think sometimes we're prone when we think about APIs. Well, yeah, I'm not working on APIs. I'm not working like some big REST application or something like that. Maybe I'm doing low-level systems programming or something like that. But any method is an application programming interface, right? And so he's talking about creating an APIs that are simple, not just for customers to use, but for other developers to use. And he talks about that idea of pulling complexity downwards, that we as developers basically says, look, if something has to be complex, it is way better for the designer of the software to deal with that complexity than for the user of the software to deal with that complexity. So contrasting the Unix file IO with the Java buffered input stream, right? How much complexity is there that the developer has to deal with to set up this file reading at the beginning versus how much is there, with Unix, I just use the read command.
One of the things I loved is John actually has a talk at Google on the book, and he's able to talk to some of the software engineers at Google. And this came up in the conversation about the Java buffered byte stream for reading files. And someone asked him, well, how would he have implemented this? And he goes on to say, well, it should have been the default, right? When I'm reading from files on disk, that the buffered input should be the default. And if I want to choose not to have buffered input, that should be a more advanced configuration option. So that, the default behavior is this very simple thing to interact with. And then giving me the more advanced tooling to do these other things. And again, as a software design standpoint, you're like, that's exactly right. We should make the default low cognitive load, easy to understand, move that complexity down. I've made some of these sane defaults, sane decisions, and yet I can still give you the tooling, right? Let's say you're an advanced software engineer, you have a custom implementation of buffered IO that you want to use, and give you an easy way to insert that at your discretion, which I thought was pretty cool.
No, I completely agree. I think one of the through lines through this book that I think sometimes we need to hear as software engineers, it's just that idea that complexity is bad, because I think as we become more senior in our careers and maybe a little self-conscious, we start to be proud that we can muddle through the complexity, right? I think when you first start out programming, you're terrified at even the terminal, right? As you get more and more advanced, you start being really proud and saying, oh, well, I can dive into all this source code. I can untangle it. I can understand everything that's going on, right? And obviously that's a valuable skill. That's what our profession calls for a lot. But that's not necessarily good. It'd be better if all of this stuff was simple. I mean, I don't remember the last time I had to dig into the Unix file read command, right? It just works. And complexity isn't necessarily something we as software engineers should be proud of, which I think would come as a surprise to a lot of engineers working. So, to me, it was a good mental check-in, and maybe for some people a mental reset, that the goal of software engineer is not to design the most complex software we possibly can. It's actually the opposite. The goal should be to make it as simple and easy to use as we possibly can.
Right.
What about so we talked a lot about complexity, right? We've talked about this idea that modules should be deeper, they should be general purpose, they should be designed for kind of the common case. Again, talking about the Java buffered input reader. One principle he talks about that I thought was fascinating was this idea of designing things twice. That when you that basically everything you do, you write it one way, right? Or you take your first crack at it, and then before you write any code or before you ship it, you should pause and say, okay, now that I know how to do it, would I do it this way again? What did you think about that, Nathan?
Yep, that was the next section I had in my notes as well. I love this idea, and it's something that I've taken personal note to try this for my next design phase. It's almost a way to give yourself permission to be devil's advocate for yourself.
Mm-hmm.
I'm going to do this initial implementation. He talks about this a lot, how university incentivizes us to be smart and clever and come up with the right answer the first time, right? I think this comes from the exam setting. This comes from being patted on the back of like getting the way of doing this. Except a lot of times we're problem solving in a way that hasn't been solved before, right?
Mm-hmm.
We're having to come up with new and creative ways of problem solving. And so, yes, maybe our intuition is the correct one, but we should come up with a second implementation, especially with these principles, right? Can I make the interface smaller? Can I make it deeper? Can I, now that I see everything out on the page, is there a way for me to make this more intuitive or encapsulate complexity? And then put those next to each other. And then he talks about making this pro-con list. Where did I actually improve this the second time? Or now am I, specializing or something in this other section? And it also forces you to spend more time in the design process, which is another area that he advocates for, which is that you really should spend time this strategic versus tactical piece. The strategic side is really think about the design before you start writing all the code. And so, designing it twice is like a forcing function, right? You have to spend more time in design.
Yeah, and I think even I think you could be tempted to read this book and say like, but I'm not designing new software that often, right? In the sense that like, I'm not on greenfield projects. I'm working on the big company moneymaker, right? And kind of and tooling around there. But I think when we talk about designing it twice, it doesn't even necessarily mean I've got my pen and paper. This is purely theoretical. This is purely architectural. I'm not doing any code yet. I think it's even after you fix a bug, take another look at it, right? Don't just pat yourself on the back and say, great, bug is fixed. Say, okay, now that I know where the bug is, now that I know what's causing it, would I fix it any differently, right? Would the surrounding code around it, could I refactor it to be a little cleaner, right? We had a problem. I used to work at a big cloud provider. We had an issue where we were being throttled by one of our internal dependencies. It was a sister team. This team basically provided information when a customer used our service. We would send customer information to that sister team, and it would provide us information about whether their account was internal to the cloud provider or not. And then we operate differently on that, right? The problem is we're getting throttled a lot by this service, right? So it kind of fell to me to look into this, to investigate this. And so the first thing I do is I reach out to the sister team. I say, well, I mean, can you increase our throttle limits when we're being throttled? And they say, well, no, we can't, right? And so now we're in this funny position where I'm like, wait a minute, so we're getting throttled. There's not even anything to do when we get throttled. Like we just, we're just stuck at that point. So then the question became, how do we got to reduce our usage somehow, right? And so I did this big audit of the application to figure out, well, when are we calling this service? How's it working? And I was shocked at looking at just our calling usage, how many patterns we had where we had set it up in a way where we're calling it way more often than we needed to, right? An example being, we had a check where we basically checked when the caller came in, they were modifying, it was called an endpoint. That was kind of one of the products we offered. So they're modifying an endpoint, right? And so the first thing we do is we check if the account is internal to the system, and then we check the tags on that endpoint, the user set tags, right? And if it has a certain amount of tags, and if it is an internal account, then some logic is executed, right? But if you look at that ordering, it's completely wrong because we're first checking if the account is internal, then we're checking the tags, right? So we're calling this service every time, even though we actually only need to know if the account is internal, if it has these certain tags, and only like 1% of our endpoints do. So all we had to do to fix like most of our throttling problems was switch it, check the tags first, and then if the tags are, are what they're supposed to be, then check if the account is internal, right? And that's one of those things where I wasn't the engineer who ultimately implemented that who implemented that ordering at the beginning. I was the one who reversed it. But I wonder if the engineer, everyone I worked with as a cloud provider was a great engineer. But if they had taken John's advice to design it twice, I can't imagine, like all the work that went into getting that set up initially. I don't blame them for once it's actually working, say, great, let's ship it. But if they had paused and said, okay, now that it's working, let's just take another look at it. Now that we know how to do it, is this the way we would choose to do it? And I wonder if they would have caught that error in the first place and realized, oh, wait, we're making a lot of calls we don't necessarily have to make. And that
this is a perfect segue into the strategic versus tactical programming.
Yes, I wanted to talk about that.
And so it reminds me, there's a quote I highlighted, which was, good design doesn't come for free, right? Mm-hmm. That we have to invest time to do this. And so if you're under constraints, if you're under pressure, if you're just trying to solve the problem tactically, you don't have room. You don't have the wiggle room for the design. And a lot of smart people, went around and said, okay, well, how do I make it just incrementally better, right? And that's probably what continued to happen until you kind of had this like larger picture view and said, oh, what if we reversed this? Or what if we inverted this one piece? That's design thinking, right? So to talk about strategic versus tactical programming, and I thought this one was really interesting. He coins a phrase called tactical tornadoes, which is one of my favorite pieces, which is these like, if you look at the number of Git commits or the number of PRs that get pushed through, these are programmers who write a bunch of code, but aren't necessarily bound by strategic thinking or aren't bound by the design process and sort of fix a lot of problems, piecemeal. The contrary argument to that is that a strategic programming is an investment mindset, right? This idea that you use these software design principles and maybe you aren't writing as much code up front, right? You're really trying to tease out that interface or solve some deeper problem that you can sidestep a bunch of tactical pieces. And of course, he talks about the fact that there's a coding methodology that I think a lot of us are using on a regular basis, which is Scrum and sprint-based software development, that really disincentivizes strategic programming and overemphasizes tactical programming.
Absolutely.
Right?
You get the ticket. It says, this is the bug. When this customer calls and uses this API, the behavior should be this, but it's actually this. So what do? You write an if statement that says, if customer ID equals blank, then behave in a completely different way. Great tactical fix. You look like a hero, but what are we doing? We're adding complexity over the long term. Yeah, I totally agree. And so when we talk about strategic versus tactical programming, he says, well, what makes a strategic programmer? He talks about this idea of investments, right? In spending a little extra time improving the quality of our software. That comes with things like we said, designing it twice, spending a little more time in the design phase, right? But something we really believe here is that we're software engineers. It's a profession. It's a job. We're not academics, right? And at the end of the day, our job is to write code that makes money. And so we can't kind of make these appeals based on, but wouldn't it look so great? Wouldn't it be so pretty? Wouldn't it be so easy to use? At the end of the day, we have to write code that makes money. And John agrees with that, right? So when he talks about how much time should you invest? His recommendation, 10 to 20%. And here's what he says. I suggest spending about 10 to 20% of your total development time on investments. This amount is small enough that it won't impact your schedule significantly, but large enough to produce significant benefits over time. Your initial projects will thus take 10 to 20% longer than they would in a purely tactical approach. That extra time will result in a better software design, and you'll start experiencing the benefits within a few months. It won't be long before you're developing at least 10 to 20% faster than you would if you had programmed tactically, right? So he's making a practical argument for this, saying, take that 10 to 20%, and in a few months, it's going to pay off. Your software will be simpler. It'll be easier to modify. You'll be developing 10 to 20% faster. Is there a little more upfront commitment? Sure. But I think all of us would say, I think most of us probably have jobs where we're not operating on such tight timelines that an extra 10% spent on any given task is going to sink you. Some of us are, right? I've been there before. But it's not, he's not advocating for any colossal changes in how your existing job is already structured. He's saying 10% more time on any given task, just to really think it through and make those investments into having cleaner, less complex code.
Yeah. My responsibilities these days is in platform engineering. So I spend a lot of time thinking about developer productivity and developer happiness. And so we spend a tremendous amount of time in this design process, right? How build pipelines work, or better shift left on security sort of initiatives. And it's a game of how do we do the strategic and tactical pieces together. And so I spend a lot of my time trying to win credibility that the strategic thinking has these huge dividends that we get over the long term. And it's challenging, especially I just started working with a new team in January of this year, which time's flying by, but to affect change, a lot of times it's cultural shifts. A lot of times it's knowing that maybe what sounds like a crazy idea is not so crazy is a really important part of this design process. And I think that 10 to 20% threshold has actually proved out pretty well for us as well, right? We're solving the immediate checklist of needs that have come up, we're not monitoring this properly, or observability needs to be improved, or builds take too long. And strategically, we go, how could I categorically transform this problem, right? And so we start, actually, our team will annotate lists of what if we reimagined the pipeline, or what if we did these things. And eventually, with the design thinking, it gives you this opportunity to say, okay, this is the time to do the investment. And recently, it's been kind of cool for us. We actually have a whole team of engineers that has been dedicated to some of the initiatives that we've been proposing. Over the next 6 weeks, we're doing a 6-week sprint where we're collaborating to solve some of these categorical pieces. And I didn't realize the framing that we were doing until I read this book, right? I didn't realize that I'd put it in I think Bezos has talked about this at Amazon. They try to build flywheels, right? There's this idea of storing energy into a system, and so that the system itself is able to.
One part of the system, you make all the parts of the system better, right? You get that flywheel turning faster.
Exactly, right? And flywheels are, I mean, again, if you go into like mechanical engineering stuff, like flywheels are so cool. They're really, really neat, and they've been around for a long time, and they're novel in how they're in their usefulness. But I feel like that's what this design thinking does. Uh, really, what you're doing is you're building these resilient systems that are easier to reason about, more maintainable. That if you need to make a modification to the system, you take this deliberate thinking of, hey, it's my duty not to make this complicated, right? It's my duty to make that anything that I'm spending time on, I need to make sure that I can reason about the system. And I think that's a really big responsibility to put on your shoulders, but it's also very empowering. You know, if you look at it and you're like, can I simplify this? Is there a way to, yeah, pretty neat.
No, I agree. And I like what you say about responsibility empowering. That's something I really took away from this book is just the degree of ownership he talks about software, right? I think sometimes we treat our software like it's this like temperamental beast, right? That we keep in the dungeon and we just try to keep happy and, touch it as little as possible. But that's not really the right mindset. Like we are the owners of our software. We're in charge of it. The buck stops here. And so how can we take responsibility for it and not just write things as quick as we possibly can, being tactical, right? But how can we be strategic about it? How can we really truly take pride in what we're creating and make it the simplest way possible?
Yeah.
Let's talk a bit about a contentious philosophy in our industry: comments. You will find people who are of the opinion that comments are useless, that code is self-documenting, right? I think there's validity to this in some cases. I personally like the idea that comments can lie to you, the code never will. But John makes a forceful and impassioned defense of commenting. I mentioned one of the quotes earlier where he says, if users must read the code of a method in order to use it, then there is no abstraction, right? This is when he is advocating for like Java comments, right? The comments above a method explaining what it does. But he even makes a case for you can have a method that is maybe 100 or 200 lines long. If that's the simplest way, he talks about that idea of change amplification. And sometimes when you look at a method and it's actually just a call to 10 other methods, well, now if I want to make a change, I have to dig into each of those methods. So he kind of points out and says, it might just be better to have all of the logic in like 200 lines of code, because when I, as a developer, and reading through it, it's all right there, right? But he says, when you have 200 lines of code, one way, if you don't want to break it out into a different method, he says, that's a great place to put a comment, right? Where for the next 10 lines, you can just have a high level comment explaining what's going on there or why you've structured it that way. Nathan, what did you think about his kind of philosophy comment?
So he was preaching to the choir on this one. I again, because of my love of Go, that community has a sort of a maximalist approach as far as inline documentation. And I think the new breed of languages that have kind of come out, whether you look at Rust or Go, Zig, the inline documentation is like a source of pride for those communities. And I think that they've really affected change in a positive way, but they've implemented it in a way that John advocates, which is, I mean, he even takes it so far as saying, you should write the comments first. You should write the comments before you even write the function. And I think on some level, he also uses this as an opportunity to talk about testing and things like TDD, which I think is a cool idea, but I think it's a lot of the same criticisms of very rarely are you in a, well, actually, it takes you into this tactical approach. He says, hey, tactically, I want it to do all these things. And then you write code to conform to the things that you want it to do. And it's an inversion of the design thinking, where I think writing the comments first is kind of does a lot of the things you want TDD to do, test-driven development, which is really think about how you want somebody to use the interface or to use the class, and then implement the code, no matter how complex it ends up becoming under the hood, and implement it in a way that whoever reads the comment can understand the cognitive load that you're asking them to take on. I'm a big fan of this, and I find that when I take the time to give that sort of more narrative comment that he talks about, of like, here's how I intend you to use this, here's the default behavior, here's what stuff comes out of it, it will inspire you to simplify, make those deeper interfaces. It'll also make you realize like, oh, this is getting complex. My comment is, 3 paragraphs long. Maybe I'm not doing this correctly either. And that's before you wrote any code, right? Like you makes you think about what you're actually implementing. Again, I know I'm like touting the Go thing here. If you actually read the spec for Go, and this is one of the things I think again is a source of pride, they wrote the spec for Go before they wrote a line of Go. So they actually wrote an entire, and you can read it in a single sitting, the Go specification. And they're also, love it or hate it, there's aspects of the Go programming language that's not for everybody. It doesn't solve all the problems. But they're a very deliberate community around how they extend the language, how they add stuff. And they do this sort of design first approach. They're very, very conservative when it comes to adding complexity to the language itself. And so when I see this broader view, not just on Go, but a broader view of software development through John's work, I see this glimmer of what I actually love about one community. And I think it's had a positive influence. Like, I've talked about this before, like Zig is a new systems level language, a relatively new one. They're not even at 1.0. But Zig is like if Rust and Go had a baby that loved ANSI, right? Like it loves this like systems level languages. And it's taken some of the ideas and design thinking that it appreciates from both communities, and I think has made a language of love for developing a community where they love to think about how these, implementation details are done. And I love that. Like, even if I don't write Zig ever professionally, I want to look at a community that is really deeply concerned about this sort of design things that they're working on, because I think I should take some of the better ideas from that and bring it back to what I'm working on as well. But yeah, I'd love to hear your ideas on the comments, or, maybe some contrarian views.
No, absolutely. I mean, so I will say that before reading this book, and I already mentioned it, but I do like the idea that the code won't lie to you, right? And I also, like, again, we're living in reality here. And so one of the problems is, especially if we're tactically programming, right, we'll just make the fix and maybe not adjust the comments surrounding that. So part of what John advocates for is you do need a culture of updating comments, right? And that's just a team culture level change that you're going to have to drive. He does advocate for, is there any sort of automatic linting we can do around comments like that, right? Like, I know that, if you're doing Java docs, for example, and you reference a parameter in the Java doc, you can have it set up so your code doesn't even compile if you then remove that parameter from the actual method, right? It's going to say you're referencing a parameter that doesn't exist anymore. So I think if I were to adopt a philosophy on my team of, hey, let's comment lots, right? That would be my first question: is what automatic tooling exists in our language of choice that can enforce high commenting standards, right? But it was funny reading this where I realized, like, because you talk about, he says, maybe write all the comments first, right? And I realized, like, that's what I do in job interviews, right? I just went through a round of job interviews, and I coach people for like kind of lead code style interviews too. And what I always recommend, and what I always do personally, is before you write any code, you want to walk through the algorithm entirely about, what you're actually going to do. And the way I do it is I write comments in the IDE and say, okay, first I need to sort the list. Then I need to put into a heap. Then I need to do this, right? And I just do all the comments, and it's a breeze writing the algorithm afterwards, because you just, I just put a new line beneath the comment, write that code, boom, move on to the next comment, boom, right? And so it was funny reading this and realizing, like, oh, wow, I already do this, but only in one weirdly specific environment, right? And it made me want to bring that to my, professional life more. And it's one thing I love just about books in general. And, if you listen to our podcast or a regular listener, you'll hear this theme crop up a lot, right? Which is the importance of engaging with long form ideas, right? I think you can see a tweet that says, hey, don't forget to comment your code. And you say, I agree, right? But then it's gone, right? But if you read a book like this, you're spending 10 to 20 pages engaging with this idea of commenting, right? And it sticks in your brain more, and it forces you to wrestle with it a bit and to think more about how you're operating with this idea in your life in general, right? And yeah, I just think there's so much value in that prolonged engagement with ideas. The world we live in today, which is great in so many ways, but I think one way that we're all maybe hampering our development a bit is just how much short form content dominates our world. It's a world of 1 minute TikToks and YouTube shorts and 280 character tweets, right? And so we get a lot of breadth of information, but we don't grapple as much with the depth as we should. And as software engineers, it's so important for us to grapple with that depth. And so, it's one of the reasons I really like this book. It's just you spend a lot more time grappling with this philosophy that he talks about. And it really causes you to pause and reflect and think, am I doing this well? Could I be doing this better? Do I agree with this or not? And that deep thinking is what's going to make us better software engineers.
Yeah, same. I hope this has a impact on my code reviews sooner than later, right? This is a great point too, of being like, I think we could write comments for this section. This person that I'm doing the code review for, they're so proud maybe of the new method or the new function or functionality, and encouraging them to take that over the finish line and being like, look, people are going to read the comments on this, let's say we're auto documenting stuff. We're going to be reading this much longer than they're going to read the implementation details. And hopefully that's the case, right? Like, again, if you've used these other principles, the way that he describes comments makes a lot of sense. If you have these deep functions, if you're writing something that's, 100, 200, 300 lines because of encapsulating complexity, it'd be really nice to have a single paragraph describing the narrative of how this is intended to function, or what cognitive load I'm expecting you to take on, right? You need to understand these 3 things that you're passing in, and here's your options for it, and here's the intended use of it. That's a wonderful way of doing this. I'm trying to think of in code that I really appreciate. In Python, there's Pydantic, which I think actually has really good documentation for how they do structured work. In Go, the cryptography library, which I think is a really important part of that community, most of that is over most people's heads, right? You can't look at the implementation details of ED25519 or something and really understand why you're XORing this together and, jumbling up a bunch of state. But if I tell you how I expect you to use it and what the inputs and outputs are and what's unsafe or what the assumptions are for, the random bits that you're throwing in, that's a beautiful way of putting the cognitive load of like, okay, cool, I've been told to implement this cryptographic algorithm. Here's how they should work. Here's some examples. And then I don't have to worry about the implementation details because, first of all, you shouldn't be worried about that. Cryptography is hard.
Yeah.
But secondly, it
was really hard.
Exactly. So that's, to me, it's one of those things where it's like, okay, well, this is definitely something that's like out of my league, right? Like, so maybe some statistical library and machine learning or some other things, like by necessity, you have to have these encapsulated complexities in place. And it's like when I look at a data scientist who's really good with NumPy and pandas, it's cool. And those are 2 examples of like libraries that do tremendous amounts of stuff and yet have encapsulated most of the complexity, right? And again, rely on really solid documentation. I think both those are 2 other communities that I think have tremendous investment in their documentation on how to use things.
I love it. I think it's so important as we talk about these things to bring it back down to earth and point out these examples that we've really dealt with. I want to just mention I think probably my favorite sentence from the entire book. He says, if your code is undergoing review and a reviewer tells you that something is not obvious, don't argue with them, right? Which I love because I've been very fortunate throughout my career that pretty much every engineer I've worked with rare exceptions, has been intelligent and driven, and I've learned so much from them, right? And I think sometimes we get a little protective during our code reviews. We say, no, it makes perfect sense. But it's like, if you're lucky, you're working with smart coworkers, right? And so if they don't understand it, like, what, did they become idiots just for this code review? Like, probably not. They probably just can't understand what you did. And again, a lot of our code should be obvious. It should be obvious to understand. And this has been really nice for me when I'm conducting code reviews with other people, that I'm feeling a little more emboldened to kind of say, you know what, I'm a smart guy. If this isn't making sense right off the bat to me, maybe it's not as clear as it could be. I had a moment like that just last week, and it was prompted by this book where one of our engineers he submitted a code review, and most of it looked fantastic. There's just one part where there was like a function called like set polling timeout, and he put just 5 as it, right? But I started thinking about the principles of this book and this principle of thinking of how do we reduce complexity, change amplification. And I thought, okay, now in the future, if I need to look at this code again, if I need to understand what this 5 means, what do I have to do? I got to dig into the set polling timeout method, right? And now the abstraction is gone because it's not abstraction anymore because I have to dig in and understand the implementation details. The moment you're trying to understand implementation, abstraction is gone. And so I felt emboldened just to say, hey, can we just make a variable instead? And we just call it polling timeout in seconds equals 5, right? And he was great. He was like, oh yeah, totally. We can do that, right? And in the past, if I had tried to make that suggestion, I think I would have felt like too nitpicky. I would have been like, well, I guess this is like the cleanest way to do it, but come on, we're adults here. Can't we just put 5? But after reading John's book, I felt empowered because I'm like, this isn't nitpicky. There's actual purpose to this. Even naming this variable different and having a little more detail at this top level here is going to reduce the change amplification effects when we need to modify this later, right? And so I think as you read these books like John's and you kind of develop your own philosophy of software design, you're coming to code reviews with almost like a little more intellectual ammo, and like obviously not in a combative way to like beat someone over the head with all your learnings, right? But you can feel more confident in the changes you're recommending because now all of a sudden it's not just, I mean, it's ultimately a matter of personal preference, but you feel that it's backed up by something, that there's real actual benefits we're gaining from following these principles that we're operating by. And I think that confidence can be really helpful when operating as a software engineer.
I think this also ties into some sort of interdisciplinary areas. I think there's a lot we can learn from the design community. It makes me think of, there's a really famous TED Talk from like 2005 called Design is the Details by Paul Bennett. And I have a feeling that these sort of obsession with the design process from other maybe more creative or graphical sort of worlds, we would learn a lot as software engineers. Right?
Absolutely.
And I think that, that whole argument with the design is in the details is that the details are exactly what matters. Like being pedantic about the variable name or what it feels like to use something, or is this a foot gun, right? This idea, can I shoot myself in the foot? Did it make it really easy for me to shoot myself in the foot if I didn't internalize the whole state structure of something? Is incredibly important. It also reminds me of, there's a lot of, I guess, apocryphal stories about Steve Jobs, but
yes.
His obsession with making like an Apple device look beautiful on the inside, even if no one ever opens it. I think it reminds me of this book as well, right? Which is that we really should care. Someone's going to open it, and does the circuit board layout look beautiful? And will others appreciate this, right? I think it's a very similar idea here, which is that if you don't worry about the details, no one ever will. And the system will get really complex and complicated. And that's our responsibility to not let that happen. Is a really cool way of thinking about things.
I love what you said about how there's a lot we can learn from other fields, right? And of all things, I actually just finished recently a Walt Disney biography. I'm a big Disney fan, right? And that was I loved reading about how focused he was on the details, right? And how he understood his films at like a micro level. I love when he's trying to make Snow White. And one of the things he's really big on at the beginning, he's like, there's 7 dwarves. No one's going to remember their names. So we've got to make them all like one note personalities, right? Like that's what's going to make, what's going to make them stick with people. And so even now, I mean, most people, this movie is almost 100 years old. And I think a good amount of people could name at least 3 or 4 of the 7 dwarfs, right? Like,
right.
Or reading about him designing Disneyland and how he was so meticulous about how he wanted the trash cans. He would like observe guests, and he realized that most people would throw away their trash if there was a trash can within like 15 feet of them. But if you start spacing them out further than that, then good-meaning people will just they can't figure out where a trash can is, and so they'll drop it, right? So he was really meticulous about making sure the trash cans, there's always a trash can anywhere in the park 15 feet apart, right?
Oh, wow.
And I see, I see crossover with what we do in software, right? Just being so meticulously focused about those details. There's a lot to learn, right? And I think it's something that we really believe here on the podcast is just that all of these books that you can read, they all start to blend together. And even I just finished Refactoring by Martin Fowler a few weeks ago, right? And as we're talking about, as I'm reading this book, the two are starting to line up because I'm thinking, okay, well, John's talking a lot about the changes we should be making, but Martin's talking a lot about how do we actually make those changes, right? And so it's fun to see as you build up your library of ideas, especially as you do it by reading books, right? They all start to play together, and in a way, it's a flywheel, right? This flywheel of knowledge starts to turn faster and faster and faster because you're operating with more ideas to begin with.
Yeah, I love that.
Well, I think we both really enjoyed this book. Nathan, who would you recommend this book to?
Yeah, this is a great question. I think that no matter where you are in your career, you're going to get something different out of this, right? And so I think anyone who cares about the sort of craftsmanship of how to build things that are intuitive, I think anybody who has that spark, this is the perfect book to give them, right? Somebody who's hungry to say, I want to build some sort of system or some open source library, or maybe they want to step up to the next level of not just writing code, but actually designing systems. This would be a beautiful book to give. I think I don't know, recent graduates all the way up to somebody who maybe has been doing this for 20 years. And
absolutely.
Yeah, there's such a depth of knowledge in this that I wish I had read this 10 years ago, right? Well, of course the book didn't even exist 10 years ago, but or maybe it did. I don't know when this book came out.
I think it's relatively new. I think it's like 2019.
Okay, well, good. Yeah, this is one of those where there's a lot of aha moments where I've kind of built up intuition. Some of them were new ideas that I'd never heard voiced before, and some of them I were like, yes, yeah, this is just beautiful prose for something I agreed with. But it doesn't get deeply technical, so I think a brand new programmer could read this. I think they're going to miss a lot.
Yeah,
and then I think an advanced programmer they'll appreciate the perspective and maybe not agree with everything, but hopefully it challenges some of their beliefs, because I think that's the best books do, right?
Absolutely. And I think we've spent a lot of time talking about what we agree with John on throughout this podcast, right? That's not to say we agree with everything. I mentioned a little bit where, I think there is validity to the idea that, again, comments go out of date, and maybe we can be overzealous with commenting, right? And so I wouldn't want anyone to read this book and to think, oh, finally, the Bible on how software should be written, right? Let's all do this. It's just, it's another set of ideas. I think a set of very well thought out and well backed ideas. But that doesn't mean that it's the gospel truth.
Right.
I would recommend, I don't know if I would recommend this to new grads. I like what you're saying, kind of like if you were to give it to a new grad and be like, here's a preview, just let these ideas marinate in your head, right? And maybe inform some of your decision making. But in a lot of ways, because this book is kind of a rebuttal to a lot of common industry programming practices, I think you would get a lot more out of it if you had been in the field for 2 or 3 years, right? I know, especially at the beginning when you're starting out, I felt this way, at least. Like, I just felt like I was drowning and trying to just keep my head above water. That, like, I mean, if you're drowning and trying to keep your head above water, you don't want someone to swim by and say, hey, by the way, do you want to know how to do a perfect breaststroke? I'm like, what are you talking about? I just need to not drown here. So I don't know if a new engineer would get as much out of that, but I certainly wouldn't say don't read it. But I think anyone who's been who has a couple years in the field and is especially starting to be a little more curious about if there are other ways to do something, right? Like, you start to kind of challenge that environment you're in and say, is this the only way software can be written? This is a fantastic book, because this is going to expose you to just a completely new philosophy of how you might write your software, right? And then I would also really, really recommend this to anyone who's a big fan of Uncle Bob's Clean Code. Just because in so many ways, it is a rebuttal to a lot of those ideas. And I just think you're going to gain a lot by really comparing and contrasting those two, right? And I would encourage you not to ultimately side with someone, right? Someone's ideas might be better in one respect and someone's ideas might be better in another. But I would really encourage you just to try to take the best from both of the books as it sits right with you. And again, just that wrestling with new ideas is going to either lead you to adopt new, better ideas, or to be more confident in the ideas you already have, right? And both are great outcomes as a software engineer.
Yeah.
Yeah.
I love that. Yeah. I think this will kind of take us full circle. In the preface to the book, he actually says, I recommend that you take the suggestions in this book with a grain of salt.
Yeah.
And again, I appreciate he has everything is a very balanced view of like, yes, expresses all these opinions, but he's like, yeah, take it with a grain of salt. Like, that's again, I deeply appreciate that because I think we all should.
You don't expect a guy who's so motivated to write a book about how you should design software to be pretty even keeled about it, right? It's like you said, like he's not combative in this. At my current company, we have a model where we talk about strong opinions, weakly held. And I got a lot of that vibe from this book, right? John has obviously thought a lot about his opinions. I think they're very well researched. I think there's a lot of merit to what he talks about, but he's not so dogmatically committed to them that he's not willing to consider other ideas. So I think overall, A Philosophy of Software Design, great book, highly recommended by both of us. And we encourage you to not just listen to us summarize it on the podcast. I think Nathan would agree that there are so many things that we didn't even begin to touch on, and the things we did touch on, we just scraped the surface on. So don't just follow along and listen to us talk about it. Pick up the book, read it yourself, right? It's a short read, less than 200 pages, right? And as you read it yourself, you'll develop your own opinions. You may disagree with us, right, about what we've said, and we welcome that, right? You can find us on social media, the Book Overflow Pod. We're on Twitter. You can reach out to us at contact@bookoverflow.io. If you had a disagreement about something we said in this podcast, please make it known. We'd love to chat about it further, maybe even have you on the podcast as a guest if you feel very passionately about it. But thank you so much for tuning in and listening. We really enjoyed the book. We hope you enjoyed our discussion, and you have a great rest of your day.
Awesome.